Okay, hello everyone. Good morning. I hope you are fine and healthy. Today, this is the video summary for the week of from 10 May till 14 May, from Sunday 10 May till Thursday 14 May. In this week, we started a new chapter, which is lesson 11.1, which was about scatter plots. Scatter plots is a normal plots without is the similar as the graph that we used to take earlier without connecting a straight line. It's just a coordinate points with x and y, and you plot the points. But what is the main purpose of scatter plots and why do we use them? Scatter plots are similar to line graphs in that they use horizontal and vertical axes to plot data points. The main use for scatter plot is to show how much one variable, in this case our variables are x and y, always remember, is affected by another. How much the x or the y variable, like the y variable, is affected by the x. Why did I say the y affected by x? Because as we took earlier, x is the independent variable. It doesn't depend on y. It is independent, and always y depend on x. So that's why we can say that scatter plots shows how much one variable, which is in this case the y, is affected by another, which is the x. Okay, the relationships between these two variables is called their correlation. Correlation is the relationship between these two variables. Now, as we go on, we're gonna highlight and define what do we mean by correlation and what kind of relation we are talking about. But first, we need to take an example or to learn how can we do a scatter plot. How can we graph a scatter plot? For this purpose, let's take an example. I'm gonna use an example outside the book just to show you. First of all, this is 11.1. Okay, page. For now, I'm gonna use page 5, 8, 2, and title of this lesson is scatter plots. Okay, scatter plots. This lesson is mainly divided into two parts. The first one is how to graph a scatter plot, and the second one is how to interpret a scatter plot. How to understand the meaning of the scatter plot. What does it mean? What does it imply? What kind of relationship do we have here? And so on. The first part is very easy, but we are just going to do an example to give you an idea about what we are talking about. How do we graph it? Right. So let's say this is question one. And the question, let's say, compare number of hours worked to what? Number of hours worked, hours worked versus wage versus profit, or we call it wage. Wage is the amount of money you gain for working. It's like your salary or your income. Okay, so hours, let's say time versus money, in other words. So, and let's say we have this table. I got this table to show hours, which is the X value, and wage, which is the Y values. Okay, so what are my X and Y values? Let me think of the numbers. Okay, for wages, let's say 1 hour, 2 hour, 3 hour, 4, 5, 6, 7. So, and okay, um, starting from 50, 60, 70, 120, 90, 4, let's say this is 80, this is 75, change the value a little bit, 55, 60, 65, 100, this one, let's call it, so this is 100, 120, 135, and 200. These are the values that we need to use. These will help me a lot in explaining mainly everything. In order to graph it, first let's draw our x and y coordinate. Okay, this is my y axis, and this one is my x axis. First, let me decide about my x-axis. So it's 1 hour, 2, 3, 4, 5, 6, 7. Up till 7. This is all what I need. For the y-axis, guys, you need to decide about your range of y-axis. As you can see, it's big. We started from 50 and we end at 200. So it's kind of not easy to fit all of these values in the y-axis. So we need to decide about like a range. For example, let's say I'm going to start from 50, because this is our first value. But then we need to decide each square on the graph is equal, like how much in terms of money, the wage. We need to check how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have around 10. So let's say 50, 60, 70, 80, 90, 100. Okay. So maybe 20, 70, 90, 10, 130, 150. Yes, let's say around 20. So this one is 70, 90. Just writing it down so you don't get confused. 110, 130, 150, 170, 190, 210. You can continue, but this is all what I need. Up till 200 actually. No need for 210 even. Okay? Fine. Now let's plot the points, our points. I'm gonna use the red one. At 1 hour, it is 50. At 2 hour, 2 hour, it's 55. So something like here. 3 hour, it is 60. 4 hour, it's how much? It is around 100. 100 is here. 5 hour, it's at 120 here. 6 hour is at 135 here. 7 hours is at 200. Okay, this 1, 2, 3 at 3. Let's make it 70. This is 70. So this is the first half part of the lesson, is how to graph these points or how to plot them. This is what I call, or what we call actually, scatter plots. Scatter plots. This is a scatter plot. Okay. Now, from these points, I told you we use it mainly to know the relationship between two variables, or how one variable, which is the y, is affected by the x-axis, or by the x, which is in this case the time. Okay, we have, before I start the second part, now we need to learn and understand how can we interpret these kind of graphs. How can I know what do I mean by this kind of graph? Okay, so if you go to page 583, there is a full explanation of what I'm going to explain. To interpret this graph, mainly we have to compare three kinds of, what do you call it? Parameters, let's say. We call the first one the variable association. Association is the relationship. Variables, in this case, it's x and y, or if you are talking about this example specifically, it's going to be the x, your time, and the y, your money. So time versus money, what's the relationship between these two? And the linear association, is it a linear or non-linear? And if you remember in the second term, I think the first one, I'm not sure, we took on how to identify whether it is a linear or no, and we need 4 conditions. One of them was whether the graph is a straight line, and another one was the power of the variables x and y. Is it power 1 or power 2, if you remember? And we had also, can I write this equation in terms of y equal mx plus b? In this case, all what you need to remember and recall is this graph a straight line? Or if I connect a straight line from between all of these lines, are all of these points going to lie on the same line, or near this line, or far away from this line? We will see now. And the last one is, we call it outliers and cluster points. I'm going to explain it in a minute. Right, I'm going to use the same graph. So let me erase the question first. This one I don't need it anymore. Here, let's say I have this graph. I told you the first type is called for interpretation. For interpretation in discuss. And I'm gonna change the graph a little bit to just make it easier to explain whatever I'm explaining. Okay, let's say like this. Yes, and need one more point. No. Okay, like this. Yes. Okay. Yes, this is enough. Now, so the first one is, we said, the variable association. For variable association on page, I told you, let me write it first. Variable association. Okay. Guys, this is on page, how much? Also, page 583. It's very important. Okay, this is an explanation for whatever I'm going to discuss. For variable association, we mainly mean, is it positive or negative, the relationship here? Positive if x and y, if as the x increase, what happened to the y? Does it increase or decrease? As you go from left to right, when the x is, look here, from x1 to 2 to 3 till 7 hours, what happened to the y? Look at the points, they increase, starting maybe from 50 till up. So this is a positive association. Again, for the associations, it's either positive or negative or no association. No, I'm not gonna write association. This is just a shortcut for association, like this. You have these three options. If the points were something like this, for example, this is a negative association because as we go from left to right, as the number of hours increase, the amount of money, what happened to it, decreases. Okay, and we're gonna take some examples to show you positive, negative, and no association. Okay, this is the first thing. So the relationship between the two variables. What happened to the y when the x increased? Does it decrease or increase also? Positive, negative, or no association? Now regarding the linear association. How can I know if this is linear or not linear? Linear association. How can I know whether it is linear or non-linear? As simple as, look guys, I'm gonna just prove it to you. If I try to connect a straight line between all of these points, ignore this, the last point, which I didn't include, and later you will know why. As you can see, maybe not all of the points are on the line, but they are really close to the line. So we call this linear. As far as the points are on the line or very close to the line, we call it linear association. If the points are far away, we call it non-linear association. Non-linear if it looks like a curve, okay? And if the points are scattered, look here, like let's say the points are like this. This, I call them. This is no relation, no association. Not linear, not non-linear. I can't say anything about it because linear means what? Straight line. Non-linear means curved, but it's a connected line. The dots that I just draw are not, we can't connect them in any possible way unless it's gonna be really messy. So if I can connect a straight line like this yellow line where most of the points are on the line or very close to the line, we call it linear. Okay, let's keep this yellow line. Okay, so the two options that I have, either linear, non-linear, linear, non-linear, or no relation, let's call it. And the last thing, we call it other patterns. Other patterns have two things mainly. Other patterns. Mainly outlier and one out. Two is cluster points or cluster. I'm going to explain on the graph these two things. Okay, first of all, for outlier is a point, or maybe it can be more than one point, who are not following the pattern of the case or situation. Like this point, can you see this point? It's way far from the rest of the points. So this give me this implies to me that there is something wrong here happened here. I can't take this to generalize on the case. Like in this case, we are discussing the amount of money an employee earns depending on the hour he's working. So this one is implying if he worked for 7 hours, he's gonna get around $200, which does not make any sense or relation with the rest. So this is like a biased biased case, let's say. So I don't take it into my consideration when I'm generalizing the case or trying to understand the relationship. I call this point an outlier. Outlier is a point that does not follow the pattern or the rest of the points. Okay, and we have also something called cluster points. Cluster points is the gathering of points. Points where areas, small area like this one. Look, if you notice here at the beginning, have a lot of points like 1, 2, 3, 4, 5, 6, 7, 8. I have 10 points. It's really crowded in here. Between what and what? Between here 0 and the 3 hours. This is 3, and between 0, let's say, and where 70, around 70. These area, small area, is really crowded with 10 points. Look at the rest. They are really spaced and far away, spread really well on the graph. But this area is really crowded. So I call this cluster points. Points that are gathered together. That's a collection of points that are really close together. Collection of points. I'm going to write the definitions, even though it's available in your book, just for your reference, okay? So cluster points, collection of points that are close together, that are close together. Okay. And outlier means it's a point that does not fit the pattern. It's a point that does not fit the pattern. Okay, does not fit the pattern. Is it clear? Point that does not fit the pattern. Okay, this is in terms of explanation, and everything that I explained is available on page 583 in your textbook. There is an explanation for the outlier, for the cluster points, linear, non-linear association, positive, negative, no association, all of this. I'm going to solve an example. Let's choose an example to explain. Question 2 on page 589. Question 2 on page 589. Page 589. I want to solve question 2. Okay. Question 2, page 589. 8 minutes to draw the question. Then X and Y, no need to label them. I'm just going to label. So 200. Or 200. 600. 800. And 1000. This is for the number of pieces. I'm going to write the question but first, let me finish. 100. 200. 300. 400. Okay. So mainly this is what time in minute. The y-axis is your time in minute, and the x is what number of pieces. Number pieces. Like this. Okay, number of pieces. So the question says, does Kepler shows the relation between the number of pixel puzzle and the number of minutes that are recommended to complete the puzzle? Interpret the scatter plot. You need to interpret it. It's given to you. I'm just gonna draw it. The points are between 100 and 200. Here, yeah, 1, 2, 3. 150, 500, 1. Mhm. 800. 8 more than 250, 800 and something like this here. No, like this here, yes. 1.0, so that's 1,400. 1 point here. Can you see? These are my points. When they say interpret, it means you need to discuss three things I told you: the variable association, the linear association, and other patterns if we have. And your answers should look something like whatever I'm gonna write now. This is, you call it a sample answer. First of all, is this a positive or negative association? As we go from left to right, from 200 to 400 to 600 like this. And for on the y, from 100 to, what happens to the point? Does it increase or decrease? Does it increase or decrease? The answer, it increases. So we can have a positive association. Say, as the number of increase increases, time increases also. You see, I started by the x because this is the independent variable. Number of pieces does not depend on the time, because as the number of pieces of a puzzle increase, the bigger the puzzle is, the more time it's going to take me to finish it. So the number of pieces does not depend on the time, but the time it requires to finish the puzzle depends on the number of pieces. This is very important for you to understand. So what? So we have our scatter plot as positive. Positive association. Is it linear or non-linear? How can I know? It's obvious that it's linear, but let's try and connect the straight line. Can we connect the straight line? From this point, maybe something like this. What do you think? Yes, it is linear because the points are really very close to the line, or they are lying on the line itself. So, what the definition is linear? Using different colors to differentiate all three kinds of association. Negative or linear nonlinear association is Now the last thing, which is other patterns. Do I have any outlier or cluster points? But okay, do I have any outlier or cluster points? What do you think, guys? Do I have? First of all, do I have any outliers? There is no outliers. As you can see, all of the points follow a specific pattern. There there is no outliers. Just write no outliers. Um, and the last thing is, do I have any cluster points? Yes, at this area, even though I draw the line above it, as you can see, at this small area, I have 3 points clustered together. So yes, there is one cluster point. There is one cluster. There. One cluster. Now, at the beginning, since this is a new idea for you, you're gonna be confused a little bit about deciding if we have any clusters or no. But how did I do it? Look here. Here only 1 point. Here 2 points, 1 point. But at this small area, there is 3 points. In 1 square, we have 3 points. Consider it this way. 1 square, I have 3 points. So this, I consider it a cluster point compared to the rest of the points. And you see here, I have 3 points. In some cases, you might, depending on the case, you might have 10 points. And still, it's considered a cluster point, cluster area where more than 1 point are gathered together, close collection of points close to each other as we define it. Okay, this is a sample answer on how you should interpret your scatter plot. It's easy, but you need to practice it and get used to it. Thank you so much. This was a summary for the week of from 10 May till 14th May, third week of Ramadan, lesson 11.1. Thank you so much. Have a nice day.